like whenever the DO is inverted as a 1, so it will become a subtraction. If let's say it is not inverted, it will become as an addition. So that is the mainly concept of transferring from the addition to the subtraction. So this is the one bit of uh, full adder because we have only one A and one B. Okay, one bit only. And we have one output, one bit of output, and we have a one bit of two inputs, which is A and B. Okay, and then of course we have another bit is for the C in. So if you can see here, the first thing that you have to do is you have to design a 4-bit of ALU. So the universal arithmetic unit is 4-bit of ALU. So firstly you have to draw the complete logic circuit by using the basic case and or dengan XOR. So that means you have to draw the basic gate of full adder by using the AND gate, OR gate, XOR gate, something like that. And then you have to connect to the XOR because we have another XOR lah, kan? So first you have to do the simplify this full adder into the basic gates, and then you have to connect with this XOR. Okay, the additional XOR. So to become a subtractor. After that, the final one, after that, the second thing is do the Boolean expression for each. For A, what is A? For the B, what is C? For the K. If no, sorry. Boolean expression for the S and C. After you got your circuit diagram, right, you have to do the Boolean expression for the S and C because our output is S and C because we already have the logic gates, right? We have because it's like OR gate, full adder. If not mistaken, we will have like two XOR, and then it will combine. It become AND gate, or I think I'm not sure. I forgot actually. So we have the some basic gates, right? Then for C out is will be something, right? For the S will be A XOR with B, right? Something like that. Okay. The simple gate punya Boolean expression lah. Okay, and then the Verilog submodule. So you have to write a code based on the one bit of full adder. After you have write the full adder, now the second thing that you have to do is you have to draw the complete 4-bit by cascading the 4. So cascading means like it taking the C in into C out as a C in, C out as a C in, C out as C in. So you have to cascade your 4 full adder. So if 4 full adder means you will have 4 things and you will have XO or right. And then that means you will have 4 O, A1, A2, A3, and you will have BO, B1, B2, something like that. Okay. So A1 and A3 means 0, and then you have the carry wires, the final sums, and the K connects. So that means the final one is basically is you just draw a block of 4-bit of full adders. That's all.
Madam,
Yeah.
the first one I not really
This
understand
one.
what do you get. Yes.
Okay, this one is like a because this is actually this is your assignment. This is what basically you have to do. If I tell the
Oh,
answer is not good lah, kan?
oh, okay.
So the tips is you have to expand this full adder by using the basic aids. Did you remember your lab 3? We
Yeah.
are doing the lab 3 from the half adder. We started with the basic aids.
Oh,
You only
so
have
saya
the
nak
extra.
expandkan dia secara logik lah.
Yes, logic by using dia dah bagi dah AND gate, OR gate dengan XOR sahaja.
Okay, faham.
Kat situ. Tapi yang ini bukan untuk half adder, tapi yang ini adalah untuk full adder. Okay. So
Okay,
saya
okay,
rasa yang ni
baik.
cukup senang, simple je sebenarnya. Yang ni just buat basic gate and then yang ni just write you punya Boolean expression based on your punya gate. Yang ni you punya submodule untuk satu big full adder yang macam kita buat dekat lab sebenarnya, lab 3 tu. Yang tu je. Yang full adder tu. Okay, yang untuk soalan satu ni, maybe by today you will understand what to do lah. Okay. Okay. Kita faham ada yang ada nak tanya apa-apa ke? Okay, this one deadline adalah 24 bukan 25 sebab kelas diorang on Thursday. So kelas saya on 24. So Wednesday you have to submit 24 June 2026. Okay, next week Wednesday during the class hard copy. Okay, now we go to our class. Okay, attendance ada dekat e-learning, boleh masuk. So, like last week, we have done with our, what we say, we have done our yes.
Madam, e-learning apa attendant ada password?
Ada password? Kenapa ada password? Kenapa ada password lah? Oh, dia yang style baru ke? Okay, dia punya password ni WGWDG6. Betul tak? Boleh?
Start madam.
WGWDG6. Saya masuk dekat ni. Dekat ini. Boleh kan? Okey, boleh.
Okay, dah boleh madam.
Okey, saya pun tak tahu. Tiba-tiba ada password. Alah, alah. Saya nak. Rekod. Start. Okay, so kalau if let's say the previous week we have learned on RAM, but it's particularly on the SRAM. Okay, before we go further to our designing parts and so on, today I just want to give you a very slightly difference of SRAM and DRAM. Okay, SRAM is a cache memory. Okay, is a cache memory. And DRAM is something, the one you can say like a hard disk of our kita punya laptop or our this one lah, our monitors, everything. So if you see, SRAM is look like a chip. So like previously in the previous week, I have mentioned you that okay, whenever the first thing the laptop will store their data, the first place will be at the cache memory, which is our SRAM, because it is very fast and so on. Okay. And the second thing is it will be saved at the DRAM if you really permanently want to save the particular data. Okay, it will save the data. So if you remember, if you, I'm not sure if ever you have seen these inside your if me, I have seen this one in the last PCs, right? In the monitor, when you open your monitor, can see something like this, and then you will have like a one, two, three, four. Some PCs will have like a two, some PCs will have like three. Okay, so these are the DDR. We call as a DDR, the stack. So how many of them is like some kind of the place to so save the data. Sometimes if like last time when I was using PC, right, I have this DDM, so the DRM, so the DDR, I'm only telling you that that's the one, okay? So the DRM, so if let's say you're having some kind of problem with your PCs, I just take the cover of the monitor and then I take this one. You see the yellow color, this one? I just rub using the erasers. I just using the erasers and then I just put it back. I'm not sure whether you have done this one also for now, because in laptop also we are using the same thing. But in laptop is quite risk, right, to open everything. But in monitor it's very easy because it's a more uh, reachable actually. You just can take it out, plug it out and plug in. Yeah. Okay. So this is what we're using the DDR mainly on the DDR. So we have a different things. Okay, here is a mobile RAM. If like for mobile, the usage for the mobile LPDDR, and for the GDDR is the GPU memories. So we have the different types of the DRAM. So this is the types of DRAMs. Okay, DRAMs. So and we have the old one, EDORAM and RDRM. So this is the very previous CPUs one. Okay. So when we have, for example, like in a DRAM, I'm talking about DRAM. So when you're using a DRAM, the main thing is we have the power inputs, A, okay. So, and then we have the D, which is the datas. A is the inputs, okay. These A are all is the input. And then D, we have a datas. Okay, in the DRAM, what the difference between the DRAM and SRAM? SRAM and DRAM is almost same. The pin is almost same. But the only one thing that difference between the DRAM and SRAM is this RAS and CAS. So these are the two different, one different thing between the SRAM, because here you will be using 1 marks. When you're designing, you can see that you will use 2 to 1 marks in order to identify either is it we have to use row or we have to use column side. Which side we have to use, whether it is a row side, or is it should be a column side. So that is a selection that we have to make. So that's why DRAM is much more slower than compared to the SRAM. SRAM, we don't have such thing. We just directly go to the our memory side. So that is the one main difference between SRAM and then DRAM. Okay. So directly you go to our first examples. Okay, now if you can see here, we have a 16K times with 16 RAM system using capacity of 1024 words of 8-bit each using 2 to 4 decoders. The number of required 1K times, okay. First thing then once you have these type, okay, you have a steps. If you remember that last week also I have shown you the steps that you need to take. You have to, I told you that, okay, the first, if let's say you have a mapping, a SRAM catch, first thing what you have to do is you have to find the word offsets or the block size. And then secondly, you have to find the total number of lines. Okay, after you have find your total number of lines, then only you have to identify what type of a design mapping that we're using. Is it associate? Is it n-way associate, or is it fully associate, or is it a design mapping? A direct mapping, sorry. So what type of a mapping technique? So once we know the direct mapping technique, and then you have to draw the blocks. Okay, if let's say direct mapping, we'll have tag, you will have line numbers, and you will have your word set. So from that, you can identify. Okay, which one you didn't identify? Okay, you already have your words offset, and then you already have your line numbers, and now you have to find the tag only. So how to find the tags? So you have to find the tags. Just plus with everything and then equal to is a physical address, the total memory address. Okay, so the first thing that you have to, before that, initially I forgot one more thing. The first thing that you have to do is you have to change everything into the bits. If it is everything in the byte, so like say this one, 16K 16. So this is in a byte. So you have to change to the bit. 2 power of what? By using the formula of log the size base of 2. Okay, or you can do by a type and error lah, try and error. Okay, 6, if let's say for example 8, you just try, okay, 2 power of 2 is a 4, 2 power of 3, okay, then only is a 8. So that is a type and try and error. So this is 1024. It is a also a in a byte. Okay, if let's say it is written in the bits. Okay, this is the bits. Okay, if in bit, you don't have to do anything like you just take it a bits. Okay, if like even either it is a words or it is a byte, you have to change everything to the bit. Okay, so that is what basically that we have to do in this class also. Mm. Let me check. Okay, the first thing, so like according to our examples, okay, according to our example, the question is asking to design. We have to design, okay, we have to design 16K times with 16 RAM system. So that means our system, the total system memory, the total memory size is 16K times with 16 bits. Okay, the total capacity of the memory, and then we have a 1024 times with 8 bits. 8 bits. So this one is the each chip. This is a chip. Each chip. Okay, what does this mean is, okay, we have one chip, which is the size is, I make this as 1K lah. It will be easier for you, 1K. Okay, there is a one each, one chip is 1K times with 8 bits. The chip size is at 1K and times with 8 bits. Okay, and then how many of chips that we have to allocate for this system? Okay, for this system. So we have one system here. Okay, we have one system here. Okay, this system's size is 16K times with 16. Okay, this is the one big system, which is 16K times 16. So here we want to put chip. How many chip that we need to allocate over inside this big of system if one chip is 1K times 8? So this is what is basically that meanings. Okay, so this is what basically that means. So how many of rows, how many of the columns, we want to find the row and columns. So we want to find that thing, the main thing that we need to find. Okay, so and then another thing that I give you is by using a 2 to 4 decoders. So we will use these 2 to 4 decoders to combine all the required chips. Okay. So what you have to you have to do is, okay, number one. Okay, number one. So let me go one by one. So what you have to do is, the first thing is you have to find for the, you have to list what the everything from the bytes into the bits, and then the address line, the data with everything. Okay, let me show. Okay, from the 16K, first thing that we want to find is we have to find the target memory system. Okay, we have to find the target memory system. So we know that our total size is how much? Is a 16K times with 16. So 16, and we already know that 16K times with 16 bits. Okay, this should be bits lah. Okay, 16K times 16 bits. So we already have this one is 16 bits. So we have to change the 16K byte into the bits. So first thing that we have to change everything from byte to the bits. Okay. So we already know that total size is 16K times with 16 bits. And then we know that our word capacity is log to 16K. So the word capacity of this memory is from this one, log to 16K. So which is you will get approximately to, okay, which you will get log 16K divided by log 2. So you will get approximately to 13.966. So which is equal to 40 bits. Or we can say like 12 to power 4 for 14 byte. Okay, we have 2 power 14 byte. So this is your word capacity. So once you already have your word capacity, then we will go into for the address line. Okay, for the address line that we needed is about this one. We just take this one, 14 bits. Okay, and then we have the data weight. You remember or not, like previously we have the A and then we have the D, right, inside our chip. So that is what is basically this one, the target. We have this is our, will be our A, address line, 14 bits. And then we have the data width will be our, the D. So the D will be from the, this one, 16 bit. So 16 bits, so 14 bits, that means A13 to A0, our A just now. And then we have 16 bits. I think this one should not be big. 16 bits. Okay, 16 bits. Okay, our data will be from the, I think this one should not be 16 bits. I think maybe, let us see. Should be, because the question didn't give, is it bits or byte? Okay, let us just put as a bits. Okay, D15 until D0. Okay, this is the data, the D. You remember the chip A and D. Okay, so this is for the target memory system. So after this, after you have did for the target memory system, the same thing that you have to do for the each chip, the single chip, the small chip, this one, the 1K times 8 bits. So the total size is equal to 1K times with 8 bits. Okay, 1K times 8 bit. Okay, our word capacity is will be equal to log to 1K. 1K log 2 log 1K divided by log 2. So you will get approximate to 9.97. So which is 2 power of 10. Okay, 2 power of n bytes. Okay, and then we have our address line. Address line is equal to 10 bit. Okay, which is from A9 to A0. Okay, and then we have our data width. We have our data width, which is this one, 8 bits, which is from D7 to D0. So this is what basically that, this is the first two things that you have to do. So once you already have done this, okay, the third thing that you have to do is for the memory.
Madam, I-
Yeah,
have question.
yes.
Why the data line is A9 to A0 to A9?
Which one?
Address line.
This one.
Yeah.
Yeah, 2 power of 10. A9 to A0 is a 10 bits, right?
Oh, so 10.
Yeah.
Oh, okay. So 0 until 9, 10 bit.
Because we are starting from 0, we are not starting from 1. Everything, if you see, we are starting from 0 to 13, 0 to 15, and this 0 to 9. So that is a 10 bit, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? 10 bits.
Understand.
Okay. Okay, the third thing that you have to do is memory array organization. Okay, for the memory organization is basically the one we have to do lah. We have to find how many per row and how many per column. So this is what basically that we have to do. So how to do is we have to find the number of number of column. So which is from the sorry. Ah, it's funny. Target data width divided by chip data width. Okay. Another one in order to find the number of rows is equal to target depth divided by chip depth. So where you want to take the data width and the depth. So kita punya word capacity, this will be our depth. Okay, this will be our depth. Another one is will be our width. Okay, so kalau untuk lepas kita ada, so let's say for 1K times 18 bit, so this will be our depth and will be our width. Okay, depth dengan width. Sama juga dekat sini, this is for target depth and this is for the width. So apa yang kita akan buat adalah, okay, so target data width kita yang untuk target. Target ni adalah yang nombor 1, yang number 1, which is our target is 16 bit. So this will be our 16 bit. Okay, 16 bit divide by kita punya target dekat sini ada width adalah 8. Okay, which is 8. So saya akan circlekan dia. Target width. So here you akan dapat 16 divided by 8. Okay, so which is you will get approximately 16 divided by 8. So 2. So you will have 2 chips per column. Okay, in each column, you will have 2 chips per row. So untuk satu you akan ada, okay, dalam satu row tu you akan ada 2 kolom macam tu. 2 chip dalam satu row tu. Macam mana kalau let's say this is row. Okay, row ni adalah in terms of kita cakap apa? Row ni adalah in terms of apa kita cakap macam ni kan, row ni adalah macam ni kan. Row ni this is row. So dalam satu row ni you akan ada 2 chips, dapat 2 columns. So berapa row ada? Dia ada 2 lah. 2, 2, 2, this is 2, 2, 2, 2. So that is what is meaning by 2 chips per row for the number of columns. Okay. And then for the number of rows, what we are going to have is the target depth. The target depth over here is 2 power of 14. So 2 power of 14 divided by over here is 2 power of 10. Maybe okay, 2 power 14 and 2 power of 10. So you akan ada 2 power 14 over with 2 power of 10. So divide by, so you akan dapat 2 power of 2, so which is 4. So you will have 4 rows. So apa yang dimasukkan di sini adalah you will have 4 rows. Okay, you have 4 rows. Ni adalah you punya 4 rows. And then each row you will have 2 chips. Ni adalah you punya 2 chips. So inilah dimasukkan. So sekarang kalau based on this figure, so we can conclude that the total chips that we need is equal to 2 times 4. 2 times 4 which is 8 chips. So kita boleh cakap kan 1, 2, 3, 4, 5, 6, 7, 8. So we will have the total of 8 chips. Or you just can multiply lah 2 times with 4. Just take this one 2 times 4, multiply. So because like this one is a very small number, if let's say it is a very big number, so you will have you are going to have a very big. Wait. 2 power 4, right? So should be 2 power of, this is wrong. 2 power 14 minus with 10. So you will get 2 power 4, right? 14 minus 10. Yeah, 2 power 4. So which is 16. So you're not having, so you will have like a 16 rows. I put like dot. So the total will be 2 times 16. So which is 32 chips. So you required of 32 chips for the total capacity. So that means in one system, you need here 32 chips. Okay, where the row you should have is 16 rows, and then the chip you will have here is 2 chips each row. So that is basically that we are doing here. Okay. So now let's go another next step. So what you have to do after number 3, you already find the number of row, you already have the number of column. So now we have to do the partitions. Okay, in partition. Okay, number 4. Address line partitioning. Partitioning. Okay, for the address line partitioning, so we want to see that. Okay, we already have this one, right? How many 14 bits that we need for the 10 bits? This one, basically this one. Okay, how many that 14 bits? It's into the 10 bits. Okay, 10 bits. Okay, so that means we have 2 power of 14 divided by 2. Okay, we have 2 power of 14 divided by we like this. Okay, like this. Okay, we have 2 power of 14 for the total target chip. Total memory is a 2 power of 14. Your chip size is 2 power of 10. 2 power of 14 and 2 power of 10. So how many of the balance? So balance will be 4. Okay, 4. So what we are going to do is that address and partitioning is we will have one upper size and then we will have the lower. Okay, we will have upper and we will have lower. So the lower part, will be your this address, this one, 10 bits. And then the upper one is the remaining bits, which is your 4 bits. So total you will have 14 bits. So that means you have to do for the lower first, that which is 10 bits. So you will going to have your 10 bits over here, 10 bits of your chip, okay, in the lower part. So how many the balance one? From the total memory is you need 4 bits. So these 4 bits that you're going to fall inside the upper part. So this is a partition. You have to divide to upper side and then the lower side because your chip size, the total memory is bigger than your chip size. Okay, so this is the fourth thing that you have to do. And then, so once you already have your row, number of row, you already have your number of columns, and you already do the partitioning. So the fifth thing that you have to find is based on your how many of decoders or how many stages that you needed. Okay, stages and number of decoders. Okay, stages and number of decoders. How we want to find is, okay, inside our class, I mean inside our examples, the question is said it need a 2 to 4 decoders. Okay, 2 to 4 decoder. Okay, that we are going to design by using the 2 to 4 decoders. So what we have to do is, first we know that inside the 2 to 4 decoders means we have 2 inputs and then we have 4 outputs. This is the normal thing lah. So in order to find the number of stage, okay, number of stage, you have to find total decoding. Total decoding bits divided by input bit per decoder. Okay. So which means, so the total decoding bit means it is the basically this one, the upper part. So this upper part is going to be our total decoding bit. Or maybe if like you are confused, okay, which is the upper is the lower, just imagine that what you have to do is you just use 14 minus the 10, the memory size minus with the chip size. It's simple. So 14 minus 10 divide by, okay, how many inputs for our decoder? It is a 2. So 2. So how much you will get? 14. 14 minus 10 divided by 2, you will get approximately 2 decoders. So which means you need 2 decoders. Okay, which means minus two decoded. Let us start 224 to 14, 22 minus 14 divided by 2. So we will 14 minus 10 divided by 14. So you divide by 2, you will get 2. So it's 2 C. Okay. So two, not sorry, it is not a state decoder. It is a two stages. Okay, you need two stages. So how you want to find the number of decoder now? So in order to find the number of decoders, okay, you will have stage 1 and you will have stage 2. Okay, you have stage 1 and stage 2. So in the first stage, usually we will have decoder, one decoder, and the second stage you will have 4 decoder. Why it is a 4 decoder? Why you need 4 decoders in the second stage? Because if you can see here, okay, if you see here, 2 to 4 decoders. Okay, first decoder, it will take 2 input and then 2 4 outputs, right? So that's why, since we have 4 outputs, in the second stage, we need also 4 decoder. So that like this, something like this. So it can be attached here. So that's why we need the 4 decoders. Okay. Stage 1, you need 1 decoder, which is your okay. This one will be from the A9 to A0, and this one will be from the A13, the balance one A13 to A10. Okay. So here one decoder will take from the A13, the highest one A13, and then the 4 decoders. In the 4 decoders, you will have A12 until A10. Okay, A12 until A10. Okay, macam mana saya dapat yang A0 sehingga A9 semua tu? Okay. Okay. Apa macam mana saya dapat A0? Okay, kalau you tengok dekat sini, okay, if you refer back kita punya di sini, we have 14 bits which is from the A3 to A0. Okay, kita tengok yang ni saja. A3 to the A0. So once kita dah ada A3 to A13 to A0, okay, we have A13 to A0. So kat sini pula adalah A9 to A0. So bila kita punya chip tu lebih besar, kita punya memory tu lebih besar daripada chip kita, which is the remaining size is 4 bits. So 4 bits lebih. So that means which is A13 to A10. Okay, A13 to A0 adalah untuk 2 power of 14, which is your 14 bits. Okay, for your chip pula A9 to the A0, which is the 10 bits. So remaining kita adalah kita ada 4 bits. So untuk 4 bits adalah A3 sehingga A10. So which is your upper size is A3 hingga A10 dan kat sini A9 hingga 10. So that's why you punya upper tu adalah A13 sehingga A10 and then your lower part will be A9 to A0. Okay, so once you dah dapat, sebab itulah, so the first decoder, dia akan ambil yang daripada A13, A12 macam tu. So the first decoder, dia akan ambil daripada input daripada, okay, sorry, saya lupa, sorry. Sebab kita punya input decoder adalah 2 kan, so dia akan ambil A13 sehingga A12. So yang ni dia akan ambil daripada A11 sehingga A10. Sebab kita punya input adalah 2 sahaja. dua input, dua output. So dia akan ambil dua input which is A13 and it will take from A12. And second recorder, it will take from A11 and A10. So tapi you can ask me that, okay, why we are using 4 decoders but we only have 2 inputs? Okay, that 4 decoders will use all the same inputs which is A11 to A10. Okay, so that is what is basically happening here. So I will show you after this what we're going to, how we are going to design, how we are going to draw the thing. Okay. Okay, so sekarang ni kita dah ada. Okay, sekarang we are going to draw the things. Okay, before kita nak draw, saya nak give some of information. Okay, the first thing that we know that we have 16 rows. And then kita ada berapa? 2 chips each column. Okay, the first thing yang kita dapat. And then the second thing is, it is from the upper bit. Upper bit is will be, berapa tadi? Upper bit is only 4 bit. So which is A13 to A10. And then we have lower bit, which is the 10 bits. So we will have from A9 to A0. And then we are using 2 stages of decoder. So first is one decoder, which is A13 to A13 to A12. And then the second decoder, 4 decoders, we are using from A11 to A10. So ni adalah information that we need to draw the system. Okay. In order kita nak draw the system, okay, sekarang ni saya letak macam ni, you punya total capacity, okay, you punya total capacity adalah 16K times with 16 bits. Okay, ini adalah you punya total. Saya nak bagi dia terang sikit. Okay. Okay. So sekarang ni you will have, saya dah bagi tahu we have upper and we have lower. So kita akan ada dua. First is from the upper, which is from A13 to A10. And then we have another one lower part. We have the lower part, which is from A9 to A0. So kita dah ada dua benda kat sini. So apa kita nak buat adalah sebelah kanan, okay, the upper side kat sini, kita akan draw yang decoder punya. Okay, this side, the left side should be decoder and your right side, this is the chips yang kita akan guna lah. Okay, let us see. Kita ada berapa decoder just now? We have 2 stage. So we have 1 and then we have 4. The total decoder yang kita akan guna adalah is a 5. So you will have 5. Okay, so number 1, number 2, number 3, and then number, yes,
Madam,
yes.
tapi Madam bukan cakap 2 input, 4 output ke? So,
Okay,
kenapa
kalau
akan
untuk every decoder, kita akan ada 2 input and 1 enable for decoders. So yang output dekat sini adalah untuk enables, bukan untuk input.
Oh,
Okay. So untuk kita punya output dekat sini semua adalah untuk enable, bukan untuk inputs kita. Okay, so kita punya output. Okay, so we have our outputs. So yang ni adalah yang 2 4 2 decoder. Saya tulis lah. Yang lain samalah kan. So, you boleh tahu. So we have another one extra enable. So kita akan ada satu input dekat sini enable. So just now I told you right, we have the inputs right, this input, this one and this one. Okay, input dia adalah akan datang daripada dalam atas. So which is ni adalah daripada A13 hingga A12. You boleh letak macam ni dah cukup lah. Ataupun you nak buat A13, A12 pun boleh. No problem. Okay, kat sini pula untuk yang second stage adalah A11 to A10. A11 to A10. So this input will be coming the same. Sekejap, saya tukar nak warna pen. Okay. So berapa tadi? A11 to A10. So this one will be the input. The same input. Okay, sekarang nampak? Okay, kita punya kat sini adalah enable. Enable ni adalah yang kita punya output tu akan jadi enable for the second decoder. So this input is the additional part, A13 to A12. Okay, so kita dah settle untuk decoder. So now we are moving to the chip side. So kalau we know that the chips we have about berapa tadi? 16 rows and 2 chips. Okay, so kita ada, tapi I won't draw for 16 rows lah. I just draw a bit of them.
Madam.
Ya.
Yang atas tu yang 2 stage tu dia atas pertama ya 1 decoder, yang bawah ya 4 decoder, yang 1 decoder tu macam mana nak dapat?
Ni 1 decoder, ni 1 decoder. This is our first stage. Stage 1. This is your stage 2.
Dia mesti akan 1 decoder ke? Atau dia akan ubah-ubah?
Bukan, you have to start with 1. Okay, sekarang ni macam ni JB. So, let's say saya bagi you satu chip. Okay, sekarang saya bagi you satu chip. Saya bagi satu benda that you need to require 8 data input. Okay, tapi saya bagi you punya input adalah 2 sehingga 4 input. Faham? So untuk 2 hingga 4, you memang akan start daripada 1 dulu. Baru you sambungkan, baru the last part, you will have 8 input. Sebab you punya decoder tu memang start daripada 2 hingga 4 input. You tak boleh start terus kepada 2 input. Dia macam, you kena macam ni. Yang ingat lagi tak? If you still remember your mathematics lah. You have to start with 2. And then you have to put another 2 to become it 4. And you have to put another 2 to become it 8. You remember or not?
Yeah.
This is what is actually we have to do this. So you have to start from the initially is 2 to 4, the first one decoder. And you have to multiply again and again. So tapi it will be different if let's say I give a different size of decoder number. So let's say I give you 6 to 5, like in your assignment, I give you 3 to 8 decoders, right? 3 times 8 decoders. So that will be different. So maybe the number of decoders can be decreased. It might be. Okay. So macam ni yang you kena buat lah. 2, then 2, and 2 again, and multiply. So it's always start with number 1. And since kita ada 4 input, so that's why kita pergi ada 4 decoder. So that means kita pergi daripada 1, and then kita ada 4 output, so that's why kita akan ada 4. So lagi-lagi kita nak, kita akan dapat macam ni lah, 4 and another 4. Bukan, 4 kali 4. So you akan ada 16. 4 and 6 4. Betul, sebab ini 4. So you will get approximately to 16. So macam itulah dia akan perkalikan dia. Okay, saya rasa faham lah.
Faham.
Okay. Good. So the second thing part that you have to do is on the chips. So we already know that we have 16 chips and uh, two chips per column. So what you have to do is you have to draw the two chips. Okay, this chip is basically yang satu kali berapa tadi? Satu kali 8 kan? Satu kali 8 yang kecil tu. Yang chip size. This one, the number 2. One, 1K times with 8 bit. So this is 1K times with 8 bit. Okay. Okay, for this one, okay, so saya akan buat lagi another 2. Maybe I do a bit lah. Okay, 3. And then it's another 2. Saya akan buat untuk ni. Okay, so the total rows that you need is about approximately to 16 rows. And then you ada 2 chips. 2 chips per row. 2 chips per row, ada 16 rows lah. Tapi saya tak buat ke semua so maybe you can do after this. Okay. So for the chips, you will have one chip selection. Okay, we have chip selection. This is not our input, this will be our like an enable. Okay, you will have chip selection. So dekat mana kita akan buat dia punya chip selection tu? So di mana kita akan ambil adalah from this input. Okay, so we take this one. Okay, each row dia akan dapat satu. Now, so this one macam ni. So this one also you will have lah. But I don't know, I didn't show because like 16. So you will have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. That's why you need 16 rows. Okay, so at the end tu you akan dapat dekat sini. So kalau you connect, actually if you do 16 rows, you will be connected lah. Yang ni semua will be connected. Saya just tak nak connect lah. Saya tak nak buat banyak-banyak. Okay. So dah connect. So this is how the decoder is connect to the chips. Okay. So dekat mana kita nak tengok dia punya. Okay. Dekat mana dia punya inputs yang we calling that A9 to A00. Okay. From here, actually basically, kita akan ada satu input. Okay, we will have one input. The ori input which is A9. Yang ni lah yang input ni. A9 to A0. Okay, let's say I put as a A9 to. Kenapa dia biru lagi? Okay. A9 to A0. So there is one input yang di mana dia akan masuk dekat sini. Semua akan guna the same input. Okay. Why we are using this A9 to A0? Kenapa kita tak guna two input? Sebab kita dah tengok kan in the second one, it is a 10 bits of address line. So that's why we need this A9 to A0. So that is the thing lah. Okay, so once you dah select habis semua benda ni, so kita dah settle tak? Kita tengok tak? Okay, this one we have settled. We have settled this one and also we have settled all the bits. Okay, the last part that you have to do is the data weight. Kalau you tengok dekat sini data weight. We have D50 to D0. Okay. So the data bit is D15 to D0. Okay, kita ada D15 to D0. Okay. So, apa yang akan berlaku di sini adalah sepatutnya dekat sini the CS, okay, the here over here, you will be given the macam kita cakap apa, 8 bit. Sebab kat sini you tengok it is a 8 bit, right? 8 bit. So we have total of 16. So from this, sebab every chips you ada dia punya output juga. So kita punya output saya letak dalam warna lain pula. Output saya letak warna berapa? Warna hijau pula. Okay. So dia punya output. Okay, saya letak dia punya output. Okay, dia punya output. Okay, semua output ni apa yang dia akan keluarkan adalah, okay, kita tahu that just now D15 to D0. So ni adalah kita punya data output. So data output dekat sini adalah daripada D7 to D0, and then this is the remaining.
Madam tulis barang tak? Kerana tak nampak.
Tak nampak kan sini? Dapat? Okay, saya tulis kat atas sikit lah. Okay. Dia adalah dekat sini adalah is from the D7 to D0, and then this one is will be our from the D15 to D6. Kenapa D0 sehingga D7? Sebab kita perlukan only 8 bit. Kalau you tengok dekat sini adalah 8 bit. So we need only 8 bit. And this is will be our 8 bit. So the total capacity yang just now kita tengok adalah 16 bit. So we need 16 bit. So that's why 8 bit and 8 bit. So D0 to D7 and D15 to D6, D8. D8 to D15 and D0 to D7. So this is the design of the RAM. So ada apa-apa yang you tak faham ke? Oh my god, dah expose mata tengah lah. Okay. Okay, kalau this one just a bit of yang saya nak bagi tahu kat sini. Okay, kalau you tengok dekat chip ni kan kat atas ni. Okay, saya just nak tunjuk dekat sini a bit. Okay, kita tahu that we have okay, we know that we have chip select. Lagi dia kecil. Okay, we have chip select. Lagi kecil. Sebab saya nak buat. Okay, we have chip select. The first row, I'm only showing the first row. Okay, we have this one, and then we have CS. Okay, we have the CS from the decoder, and then we have the input. So kalau kita tengok kan, input is from the okay. Kalau kita tengokkan tadi kita punya input adalah daripada A9 kepada A9 to A0. So the same input, and then our data will be D7 to D0 and D15 to D8. Okay. So this is yang bawah-bawah ni semua yang sama. Okay, so I want to show this part only. I just want to show this part, the lower bit. Okay, this show only. Okay, so lower bit. So dekat you punya lower bit is A9 to A0 sahaja. The first row sahaja. Okay. So untuk the SRAM, so this will be your SRAM. So SRAM. The difference between the SRAM and DRAM is only the marks. Okay, we have the marks. Okay, for the DRAM, so you will have another thing is which is a 2 to 1 marks. Okay, 2 to 1 marks. So di mana kat sini you punya input adalah is not from A9. So dia akan daripada marks. So kat sini adalah you punya input which is from the A9 to A0. This is from the DRAM. Talking about DRAM. Untuk DRAM A9 kepada A0. So maksudnya dia macam mana tau? Dia akan masuk two inputs because we have two inputs, right? So we have like a two. So it will be divided to into two, which is A4 to A0 and then A9 to A5. A0 to A4, A5 to A9. So you will total of 10 bits. So dekat sini. So macam ni. Okay, apa yang difference DRAM dengan SRAM? Okay, saya letak yang ni adalah untuk SRAM. SRAM kita tak ada marks. So what is the difference by using the marks and without using the marks? Okay, there is two different things. Okay. Okay, kalau you tengok dekat sini, if let's say I give an input of A9 to A0, I just give input. So this CS, this CS will become like a chip selection. It will the select. Okay, when it do, if let's say this chip is select, okay, for example, the first chip was selected, so it will just take it all the inputs A0 to the A9 and see which one is important, then it just do it. That is for the SRAM without the marks. That's why the SRAM is very fast because you just select the chip, it take all the input and you finish it off the things. That is a SRAM. But for the DRAM, okay, for the DRAM, I told you, right, we have a CS and then we have the RS, column selection and row selection. So these CS and RS will do the work. So we put inside the 2 marks. So E do the work, okay, which row and which column to be selected. And then it give the input to the particular chip selection. So we have additional one stage for the DRAM. So that's why we say that DRAM is much more slower compared to the SRAM. That's why. So this is the one of the things lah. Because in DRAM, you need to select which row and which column and which input that they have to give. Is that either the upper input or is it to lower input, which is A0 to A4 or A5 to the A9. They have to select themselves, the DRAM. So that's why it is late. But in SRAM, this chip is selected. You just give the input. So that is the SRAM. So do you, now you understand or not how to do designing? Okay, maybe I just go through a bit. Maybe saya rasa you dah semua confused rasanya. I think already confused. Okay, the
Confused
first
banyak
thing
je.
is, it's okay. We do a lot of exercise. Okay, so let's say, first thing that I will give you the total RAM system. What SRAM is it? I want to design SRAM or I want to design the DRAM. If I say in the assignment, I ask you to draw the DRAM, right? DRAM. So you have to do for the DRAM. So once you already have your RAM size and you already have your chip size, whatever it is the inside the byte, you have to change to the bit. That is the first step. Okay, for the designing part. So what you have to do, the first thing is you have to find the target memory system. So you will do this one. Okay, what you have to do? You have 16K times it 16 bits. So change the 16K into the bits, which is 2 power of 14. So once you already changed to 2 power of 14, so you will have your address line, 14 bits. So from here, 14 bits, and then the data with 16 bits. 16 bits just from the upper one lah, 16 bits. Okay, D50 to D0. So yang tu you just matching lah. Kalau 14 bits, A3 tu ke A0, something macam tu lah, matching je lah. Okay, untuk lepas tu the same step that we are going to for the chips. Chip, okay. So we have 1K times with 8 bits, 8 bits, sorry. So 1K, you change to the bits. So you will have like approximately 2 power of 10 byte. So your punya address line adalah 10 bits. Yang mana you will take from this 10 bits. Okay, kalau 10 bits is A9 to A0. 10 bits. Okay, data width, you just ambil yang kita punya 8 dekat sini. So 8 bits. D7 to D0. Itu sahaja. Okay. So dia sebenarnya whatever that we are doing the in number 1 and 2 is basically we are going to use at the designing part. That is the main thing actually. Okay. So number 3. Number 3, we want to find how many rows and how many columns. Number of chips is how many columns. And then the total chips that you are going to use. Memory organization. I call as a memory array organization. Okay. So you just take the data width and chip data width. Where is the chip data width and data width? You see this one, the data width and data width. Just take the 16-bit divide by 8 bits. You will get 2 chips per row. Okay. And the number of row, you just take the depth. So depth is from the, this one, the word capacity, your depth. This is your work capacity depth. So you just take 2 power 14 divide by 2 power 10. So you just boleh minus je kan, 2 power 40 minus 10, so you will get 2 power 4. So which is 16 chips. So that means we need 6, this is not chips. This is will be row. Okay. 16 rows with 2 chips per row. So that means the total berapa you ada? You akan perlukan 16 tadi lah 2 which is your 32 chips. You perlukan 32 chips inside that one particular RAM system. That's all. Okay, so bila you dah dapatkan the number of rows and columns, now we go for the partitioning. So berapa line yang kita perlukan in the upper bit and berapa line yang kita perlukan inside the lower bits. Okay, the lower bits you ambil yang you punya chip size tu. 2 power of 10 kan? So 10 adalah untuk lower bit. Okay, lepas tu yang you punya main memory adalah size dia 14. Betul, 14. So 14 tolak 10, remaining ada berapa? Ada 4 bit sahaja. So untuk upper part you akan ambil 4 bit. So you will 4 bits and 10 bits. A13 to A10, A9 to A0. So total you akan dapat daripada A0 sehingga A13. Total you akan dapat macam ni. So selepas tu, so bila you tambah 2 ni, you akan dapat macam ni. Macam ni lah contohnya. Okay, selepas tu number 5, you are going to find the number of stages and number of decoders you needed. So how you want to find the stages? Okay, if you still remember, kita punya upper part berapa? Okay, upper part is 4 divide by the total input of the decoder. Total input kita adalah 2. So 4 divide by 2. Saya letak 14 tolak 10 kat sini. 14 tolak 10 ni. 14 tolak dengan 10. Still you akan dapat sama dengan 4/2 lah. Iaitu you punya upper bit ni. Ini adalah you punya upper bit. Upper bit 4 divided by 2. So you will get 2 stages. So number of decoder that we need is stage 1. You kena start dengan satu decoder sebab we are using the multiplication. So 1 to 4. So 4 to 16. 16 to how much? How much? Like that. 4 to 4. Macam ni. 1 kepada 4. Okay, because your output is 4. So 4 squared. So you will get equal to 16. So and then if not mistaken, you can 4 cube ke? 4 power cube berapa? Lepas tu you kena 4 cube. So you akan dapat 64 decoders. Macam tu and so on. Okay. So but we have only 2 stages. So we'll just stop until the 4 of square. So you have 1 decoder and 4 decoders. So sebab kita dah tahu that you punya, this is your decoder will use the upper bits. Okay, upper bits which is A13 to A10. So each decoder kita ada 2 input sahaja. Betul, we only have 2 inputs. So that's why it's A13 to A12 for the first stage, and A11 to A10 for the second stage. So total decoders yang kita akan guna adalah 1 campur 4 is equal to 5 decoders. Okay, so I forgot this one. Okay, so once kita dah habis lah. Okay, now we already know that 16 rows, 2 chip per row, and then we already know the upper bit, lower bit, how much, and then we already know how many decoders we are going to use and how many stages. Now we can go for the designing part. So first, you buat yang decoder first. Okay, the first stage 1. Okay, it is using only one decoder. And then the second stage, you will going to use 4 decoders because you have 4 output. Okay, you akan guna 4 decoders. Okay, so yang kita
Madam,
punya input, yes.
kalau semua yang design part lah, mula akan stage 1 akan dimula satu saja kan? Satu decoder saja.
Yeah, yes. Every time the first kita akan guna start daripada 1.
So contohnya dia ialah 6/1. 6/1. So bawah tu dia akan 1, lepas tu stage 2 akan menjadikan 6 lah.
Yes, kalau let's say I give you another example kan. Okay, let's say they're using 1 to 6 decoders for example. Okay, 1 to 6 decoder. Okay, kita ada 2 stage. Again, I'll be having 2 stages also. So the first one, 1, and then you will have 6. Am I right? And then the second stage, you akan ada 6. 1, 2, 3, 4, 5, and 6. So for each.
Oh, okay, faham. Thank you, madam.
Okay, faham. So you akan ada. Pasal let's say saya ada perlukan 3 stage lagi. So again, you have a 6 here and you have 6 here, right? So you have to put another, okay, 1, 2, 3, 4, 5, 6 for this one. And another 1, 2, 3, 4, 5, 6 for this one. 1, 2, 3, 4, 5, 6 for this one, and so on lah until you finish accordingly. So yang tu lah. So apa yang kita start ini? Okay, dia. So second stage, okay, kita dah buat letak input dia A13 kepada A12, A11 hingga A10. Okay, lepas tu kita dah letakkan, once you already finish your upper bit, now we go to the lower bit. So we know that we have 16 rows, and then each row we have 2 chips. So kita just write, lukis lah. So output daripada decoder will go to the chip select. Okay, the first output we go to the each row. Like one output for the each row. One output for the each row. That's why I'm telling you. Okay, if you remember or not, for the SRAM we have read about 3 types of techniques, right? Direct mapping, associate mapping, and way associate mapping. This is where it's applicable. Okay, kalau you tengok dekat sini, okay, if you see here, okay, without marks. Okay, let's say if this one is a without marks. Okay, just imagine that this one is without marks. Okay, we have one chip select. So we have 2 ticks. For the SRAM, we don't know. He don't know that which one to select. Okay, it just go to the, okay, this row, I will select everything for the SRAM. So this one, it will select all the row. So which row we want to find, where we are going to use this direct mapping. Let's say I want to say that direct mapping. So go to the first chip and find your location yourself. Okay, it will go to the first direct mapping. If N-way, okay, go to the first one and this set. That is a N-way set, associate. Fully associate, okay, you just go to the first one, you just find yourself wherever you want. So that is where the direct mapping and way set everything is applicable over here actually. Okay. So kalau untuk yang DRAM, for the DRAM we don't need that techniques because we already have the SAS, CAS, and we already have the RAS. That's why we don't need this kind of where to select, where's the place that you have to save everything, because we already have the CSSRS. So that's why we have additional to study for the SRAM, the three types of techniques actually. Okay. So before I just finish it off, do you have any question or not? Okay. So ada apa-apa soalan tak sebelum saya nak stop? Atau dah confused?
Faham kot. Faham.
Faham? Okay. So I give you one slide, okay? I want you guys do at home and bring to the next class. Saya tahu that, okay, you have your assignment to do and you have another 2 questions that I'm going to give you. But this one you can do by your, by your using your groups. Okay, you sit together and study together in one day, maybe you can do lah. Maybe on Friday ke, Saturday ke, buat lah. Just for your, untuk as the exercise only. Saya bagi 2 soalan, SRAM and DRAM. So, saya akan sertakan juga saya punya video bila dah saya sampai, and then saya akan sertakan juga yang notes ni untuk you boleh tengok lah secara ni. Okay. Okay. Alamak lah, title tak lah. Okay, so saya akan sertakan and bagi you exercise so that you boleh, sebab kita pun hari ni kita buat dekat kelas 1 jam lebih je kan. So you boleh ada extra lagi of your SLT. So you can do your things at the exercise. 2 soalan je saya bagi, and then you ada you punya assignment question. So you will have 3 question. Sorry, you will have 4 question that you have to settle before the next class. You just can sit together with your groups and do. Okay. Next week kita akan buat the last revision of chapter 3. I mean for kita punya chapter 5 and chapter 6 so on lah. Okay, the last revision before you go to it. Because I know that your final will be on 15 July, if not mistaken, on Wednesday. 15 July.
Yes.
Yes, right. 15 July. So it's only 1 month, I think. Yeah, it's only 1 month. It's okay. So I will ask her, so if let's say Pan Haryanti, she want to do another class, so she said she want a bit of class of me. Okay, I will ask her if she wants. I will give another half an hour to her next week lah, if she want. Okay, so itu sahaja for today. Okay, if let's say in between, if you don't know anything, you can just text me that, but you can ask me, okay, maybe you want to do extra class ke, you boleh jumpa. Esok I will be at Power also lah. Esok saya tak ada kot. Tak ada. Next week tak ada. Next week kat University. So tak apalah, you boleh minta lah dekat bila-bila masa you rasa you nak buat some Google Meet untuk you punya soalan semua lah. Okay. So kalau tak ada apa-apa, you can saya just sharekan. Make sure you buat attendance lah. Saya rasa password saya dah tulis dekat kita punya Google Chat. Saya save as design DRAM. It's safe. Okay, dan saya dah boleh upload. Saya upload lah. Okay. Okay, sekejap, saya dah upload dah. Mana save changes. Saya dah upload dah. So kalau tak ada apa-apa, we will end our class.
Thank you, Madam.
Okay,
Thank you,
thank you.